All right. Welcome, guys, to another math class. And today we'll be talking about a very important topic: functions and relations. Yeah, what is a relation? Let's start from a relation first. What is a relation? Basically, a relation is trying to describe the degree of or at which a set A is associated with set B. The degree at which one set of elements is associated with another set of elements, that degree of association is something called a relation. Take, for instance, we have set A with elements, let's say we have set A with elements, element A, B, C, D, and we have set B with elements, let's say set B with element, let's call this x1, x2. Yeah, the degree of association between these two sets is what we refer to as a function. Are we together? So, under function, we need to learn some very, very important terminologies. And what are these terminologies? The first thing is something called the domain. In this relation, set A is the domain, meaning the relationship starts from this particular set. This set is the author, is the originator of this relationship. The relationship is dependent on the elements of set A. Set A, the relationship would lead to something else from set A, and this other is called the range. So this is more or less like the x value in a function, and this is more or less like the y value in a function. So the domain is the originator of the relationship, and the range is the result of the relationship. So domain and range. And something else we need to pay attention to is the element of your domain is called your pre-image, and the element of your codomain or your range is called your image. Well, we can call this basically the codomain, the y value, the codomain. And the reason why we sometimes refer to it as codomain is because range is very specific. Okay, allow me to call this codomain for a minute, and you're going to see what the range really means. You will see why I'm choosing to call it codomain and not calling it range. Now let's say we have another set. Let's call this set Z. And we have another set R. Now imagine the elements of this set are, let's say, A, B, C, and D. And the elements of this set are I, J, K, and L. Now, if we draw a map of this function, of this relation, and after drawing a map, we establish that there was a relationship between these elements that I'm drawing for you. Now you see why we choose to call this the codomain and not just the range. You'd understand it now. Basically, we know that set Z is the domain and set R is the, let's say, codomain. But now, what is going to be the range of set Z? Now, look at it. All the elements in set Z is related to only three elements in set R, which is I, K, and L, which means the range of Z is the set I, K, and L. So what is the difference between the range and the codomain? Well, the range is only the elements that have been linked to the pre-images. So it is only the elements in your codomain that have a pre-image that forms your range. Look at it. Element J is an image, but these elements J don't have any pre-image. Look at it, trace it to anything. It has no pre-image. Therefore, it doesn't count as part of the range of the function of the relation. Did you understand me? So the domain is all the elements of sets, the first set, and the codomain is the set that contains its own elements. For you to have a range, you would look at the codomain and find all the elements that have a pre-image. Remember what we called pre-image, the element of the domain. Very, very good. And if you look at it, I has two pre-images, A and B. K has a pre-image, which is C. And L has a pre-image, which is what? D. Therefore, the range is only I, K, and what? L. And does that make sense? So, the reason why I call this the range was because, look at it, the same set B, X1, X2 being the images, both of these elements have pre-images. And since both of them have pre-images, the whole set becomes the range of A. I don't know if you understand that. Rewind it, take it slow, pause the video anytime you need to pause it till you can digest what I have just said. Alright, let's move on. Let's talk about types of relation real quick. We have majorly 3 types of relation. We have one-to-one relation, one-to-one relation. And what is a one-to-one relation? Imagine I have A being my domain, and let's say a set B being my codomain, and let's say I have the elements being x1, x2, x3, and the elements Y being y1 and y2. What is a one-to-one relationship? If one element of my domain has only one image, then that is a one-to-one relationship. If you notice it, element x1 has only one image, which is y1. Element x3 has only one image, which is y2. x2 doesn't even have any image at all. This is a one-to-one relation. And what is the condition? For every element of the domain, there must be not more than one image. Did you understand it? Not more than one image. So if there is one particular element in my relation in the domain that has more than one image, then it is no longer a one-to-one relationship. Are we together? Then we also have one-to-many or many-to-one relationship. It depends on how you put it. So in our one-to-many relationship or one-to-many relation, there will be at least one element in your domain that has more than one image. Let's visualize it with a map. So let's use the same elements, x1, x2, x3. And let's say set B has A, B, C, D, E. Let's imagine these are the elements of these two sets. Yeah. Now look at it. Let's try and draw a map for this. Now look at this. If you notice, I'm just trying to draw arrows so you know the way the relationship is going, the direction. Now if you look at this, element x1 has more than one image. The image of x1 is A and C. Look at it. On the domain side, there is at least one element, at least, one element of the domain with more than one image, one-to-many relationship. Does that make sense? So that's a one-to-many relationship. And we can also invert this and have a many-to-one relationship. Or a many-to-one relation. And how would that look like? A many-to-one relation. In a many-to-one relation, there is, let me try and illustrate the member of the set, x1, x2, and x3. And let's say this is A, B, C, D. For you to have many-to-one relation, then more than one element, let me write it for you. More than one element in the domain have one common image. In the domain, having a common image. You can say if there is one image with more than one pre-image, it's still the same thing we're talking about. Or you can say more than one element in the domain having one common image. Let's try and draw the map for this. Now, if you look at the map, this is different from the one-to-many relationship. Look at it. This is different from the one-to-many relationship. Why? In the one-to-many relationship, if you look at the graph carefully, look at it. In all this, there is no one single image that has, there is no one single image that has more than one pre-image. Look at it. Just one pre-image. It doesn't have any other pre-image. It has only one pre-image. It has only one pre-image. It has only one pre-image. But if you look at your many-to-one relationship, see this element A has two pre-images, which is x1 as well as what? x2, which means x1 and x2 have one common image, A, and this is a many-to-one relation. And finally, we have basically the many-to-many relation, which is a mixture of the one-to-many and many-to-one. It means there is at least one image with more than one pre-image, and at least one pre-image with more than one image. Does it make sense? It's like a fusion of many-to-one and one-to-many. Let me just write it for you. At least one pre-image with more than one image, with more than one image, and at least, what is at least? One image with more than one pre-image. More than one pre-image. And that is basically what relations are about. Now let's go to the most important part of relation, which will be tested in your exam, which is function. A function is a type of one-to-one relation. It's very, very important for you to understand that. So, like I said, a function is a type of one-to-one relation. So basically, for a relation to be a function, it has to be one-to-one relation. And that's condition one for a relation to be a function. So condition one is the relation is a one-to-one relation. In case you don't remember what a one-to-one relation is, I could just scroll up and you see what a one-to-one relation is. See, there's just only one image for for a pre-image at most. And not just that, it is not only going to be a one-to-one relation. Another thing that is also important for a function is every pre-image, let me put it in yellow, every single one, every pre-image must have an image, must have a corresponding image, must have a corresponding image. Now let's put a function into a map so it becomes easier to visualize. When does a relation become a function? Let's say we have set Z, and we have another set R, and let's take elements of set Z, x1, x2, x3. And let's take elements of R, A, B, C, D, E. Following the conditions of a function, for the relation between Z and R to be a function, then it must look like this. And what is the important thing? First, if you notice, we have only a one-to-one relationship. Only a one-to-one relationship. If you notice it, can you see it? That's condition 1. One-to-one, one-to-one, one-to-one. That's it. And condition 2, for every pre-image 1, pre-image 2, pre-image 3, they have just one image each. One image, one image, one image. This qualifies to be a function. Are we together? Imagine there is an element 4 inside this domain, and let's call this x4. Does this still qualify to be a function? The answer is no, big no. Why? Because there is still one pre-image without a corresponding image. Are we together? So for it to be a function, this must be related to something else. I don't know if you're understanding this. I'm changing to white, so it follows consistency. Now once this has its own corresponding image, then it qualifies back as a function. Do you understand this? Yeah, that's it. And basically, well, we have something called one-to-one function. Okay, so we have something called into function, onto function, inverse function, and composite functions. It's very, very important to talk about all of those things. Maybe not, but yeah, trying to save so much time. Okay, let's just quickly go over it. Types of functions. First, we have something called into function, or let's even start from the basic one, an onto function. The fastest way to understand a function is by mapping it out. If you map a function, you understand it's really, really easy. So let's say we have set Z and we have set R. For the relationship between Z and R to be an onto function, look at it. All the elements of Z must have one image, and all the elements of R must have one pre-image. It means there must be no elements left out in both Z and in both R. I'm coming. Let's see, we have y1, y2, y3. Now imagine I have this function. This is an onto function. Why is it an onto function? Look at it. All the elements of Z has one image. First, it still follows the definition of a function, one-to-one relation. And every image, every pre-image has a corresponding image. Look at it. Every pre-image has a corresponding image. But there's something else now attached to it for it to be onto. Every image too must have one corresponding image. which means there is no element in Z left out. That is, there's no element in my domain left out, as well as there's no element in my range left out. Every single element has its own corresponding image or pre-image, no matter what the case may be. Now we have something called into functions. Now an into function is any function whereby there is at least one element in the range that doesn't have a pre-image. So for a function to be into, all the elements of the domain, that is all the elements of this. Let me try and even graph it again for you. So let's say I have Z and R as my two sets. And let's go back with our regular X1, X2, X3. And let's say we have here now Y1, Y2, Y3, and Y4. Now, if I'm mapping this, and I'm mapping a relationship that looks like this. Now, this is an into function. Why is this an into function? You understand it now. This is an into function for only one reason. Now, if you look at it, all the elements of my domain, which is X1, X2, and X3, they all have an image. Look at it. They all have an image. But look at it. There is still at least one element of my range, of my codomain, that doesn't have any pre-image. That is why this function is said to be what? An into function. Does that make sense? Does that make sense? All right. So let's talk about something else, a composite function. It's a very, very important function. It is very hard to explain composite function with English, but it's easier to explain it with a map. And we're going to be solving a lot of questions on composite functions. Yeah. Because most of your exams will come out on composite functions, f of g, g of f, h of g, d of h, and the likes. Imagine I have two elements, z, r. Let's take elements of this one to be x1, x2, x3. And let's say this is y1, y2, y3. Now imagine there's a relationship between this function. Let me try and graph it for you. Let's say it's a very easy relationship like this. Now, if I have a new set still present in this relationship, let me call that set n. Forgive my notation, please. And let's say set n has A, B as the elements, just A and B. And now let's say this image is now linked. I'm coming. Now, what did we notice? We have two relationships in one relationship. We have a function inside another function. Look at it. Z is a function of R. What did we notice? Yes, Z is a function of R. That is correct because all the elements have an image. But also, R is a function of N. Are we together? Two functions in one. Therefore, we could say that N is a composite function of R. Are we together? So we could say that Z being a function of R is something as saying Z being a composite function of N. Quite confusing, but you understand it. For the function to be composite, let me try and explain it with English. My range becomes a domain for a new function. Now, if you look at it, this is the range. Let's look at it. This is the original domain, and this is the range. But what did you notice? The range now becomes a new domain for a new function. Are we together? Therefore, see this function R of n exists inside Z of R. And that's why we call it a composite function. So the function Z of n is a composite function of Z of R of n. Does this make sense? And sometimes we represent composite function with this. Imagine I have two functions. Let's be mathematical with this now. Imagine I have a function of x to be, let's say, 2x plus 4. And I have a different function of x to be, let's say, 7 minus 4x squared. You can be told to find the composite function f of g. And what does f of g means? There is a g function inside an f function, which means it's simply as saying finding the f of g of x. Does this make sense? There's a g function inside an f function. You could also be told to find the g of f, which means there's going to be an f function inside the g function, which is going to be g into f of x. Let's see if we could solve some questions on functions, basically, and you'll be solving many questions on, okay, I can't tell you telling you to find range. Let's see if we can solve some questions on functions real quick. Let me get my textbook. All right, I've seen a question here. They said, we are given three functions here. F of x being 4x, g of x being x plus 5, and we are given h of x, a new function again, to be x squared. Now you are told to find four things. 1, f of g. 2, you're told to find g of f. 3, you're told to find f of g of h. And 4, you are told to find f of h. Okay, h of f of g, sorry. H of f of g. Let's take it one by one. The first function, f of g. Yeah. What does this mean? It means there is a g function inside f. So it means I'm going to be having an f, and I'm going to put in a g inside the f. This is the same thing as saying f function with g's function of x being inside. And how do we solve a question like this? To solve a question like this, you have to first write the exterior function, which is what? 4x. So I have to first start by saying 4x. That's f's function. Now, inside the x variable, I'm going to be putting in the g's function again. Therefore, I'm going to be replacing the x, all the x's, with G's function. Now what is G's function? X plus 5. Does this make sense? Look at it. This represents the X, G's function inside F's function. And if we open the bracket, I'm going to be having 4x plus 20. So this is f of g. Does this make sense? What about g of f? For g of f, I have f function inside g's function. So I have to write g's function first. X plus 5. And anywhere I have x in my g's function, I will replace it with f function. And what is f function? It means I'm going to be replacing this x with what? 4x. So I'm going to be having 4x plus 5. It's the reason why I'm writing it in white. That's the function that is replaced. And basically, there's nothing more to do. Therefore, the g of f of x is 4x plus 5. Very easy. Now look at it. So we should find the f of g of h. That's the third thing. F of g of h. Let's start from the very exterior function f. Basically, it means there is an h function inside the g's function, and there is this g function inside the f function. So we start from the very exterior function first. Function f. And what is function f? 4x. Very good. Now, we have to put g's function inside f's function. Are we together? So we're going to be removing this x. Anywhere we see x, and I'm going to be putting g's function inside. So I'm going to be having 4. Then the x will be g's function. And what is g's function? G's function is x plus 5. Are we good? X plus 5. Now we have done f of g. But that's not all. There is an h function inside this g. So we are going to be putting inside the g's function, anywhere we see x, any single place we see x inside g's function, we're going to be replacing it with h function. It means I'm going to be removing this x. I'm going to be replacing it with h function, which is what? X squared. I'm going to put that in green. And if I'm going to be having 4 into bracket, replacing the x with x squared. And I have the composite function f of g of h. H inside g and g inside f. This means we are having 4x squared plus 20. So this is the f of g of h of x. I don't know if you understand this. Alright, so let's go to question 4. Let me go back to my yellow. It says you should find the h of f of g. So the first thing is I want to write the very exterior function, h, which is x squared. Yeah? Now I have to put in f function inside h function. It means whenever I see x, I'm going to be putting f. And f is 4x. So I'm going to be replacing this x with 4x. Which means I'm going to be having, I'll put f in white, 4x squared. I don't know if you understand it. H function is x squared. So replacing this x with my f's function. Does it make sense? Yes, if you've gotten that. Now, if you've gotten that, that's not all. I have only succeeded in putting f inside h. I also have to put g inside f. Are we together? And it means whenever I see x, the variable, inside g function, I'm going to be replacing it with function g. And function g is x plus 5. Which means I'm going to be having 4 into bracket x plus 5, close bracket, all squared. Does this make sense? I have put this function inside this f function. Did you understand it? The variable x has been replaced with this function. So this is my h of f of g. And that's not all. I could expand the function, and I'm going to be having, let's do what is inside the bracket first. We're going to be having 4x plus 5 all squared. And we can open this function, and this is going to give us 4x plus 5 into 4x plus 5, which leads us to, if we FOIL this bracket, we are going to be having 16x squared plus 4x times 5 is 20x plus 5 times 4x is 20x. 5 times 5 is 25, which takes us to 16x squared plus 40x plus 25. So this is h of f of g of x. Does this make sense? I don't know if you understand this. Okay, let's take another question. Probably this should allow you to understand better. I don't want this class to take too long, as it's just an introduction class. We'll still solve more jam questions in our next class. Let's say I have a new function. Let's say I have function f of x to be given as 3x squared plus 2x plus 4. Yeah? And I have a g of x to be given as, let's say, 3 minus 2x. And I have, let's say, an h of x to be given as just x 3x. Let me even use a different number. Let's say 5x squared. Please don't write everything in yellow, so I don't cause confusion too early. Now the question says, find 1, f of g, 2, f of h, 3, g of h, 4, h of g, or let's say g of f, let us do g of f, and 5, f of g of h. Imagine this is the three functions you are told to find. Let's start from f of g. If we start from f of g, following what we have learned before, it means g's function is inside f. So we are going to start from the exterior, f. And we are going to be writing 3x squared plus 2x plus 4, which is f. And inside every x value, we are going to be putting g's function, which becomes 3 into brackets. What is this function? 3 minus 2x. Let me put it in white so you can always understand it. 3 into brackets. 3 minus 2x. Are we together? Plus 2 into brackets. 3 minus 2x. Plus 4. What did you notice? I inserted this function into every x variable of f's function. Does that make sense? Because g's function is inside f. This is g inside 3x squared. Oh, we're not done. This is g inside 3x squared. And this is g inside 2x. Does that make sense? We are still not done. Let's expand the entire bracket. From this, I can expand this to be 3 into brackets. I know you know how to FOIL the brackets. 3 minus 2x all squared. If you FOIL this bracket, we are going to be having, well, for those that don't know how to FOIL brackets, just do 3 minus 2x multiplied by 3 minus 2x. And if you do that, you should be having something along the lines of 9 minus 6x plus 4x squared. If you FOIL properly, sorry, not minus 6x, minus 12x, sorry. So you should be having minus 12x, 9 minus 12x plus 4x squared. For those that don't know how to foil, 3 times 3 is 9. 3 times minus 2x is minus 6x. Minus 2x times 3x is minus 6x. Minus 2x times minus 2x is plus 4x squared, which takes us to 9 minus 12x plus 4x squared. I believe you should understand that now. Yeah, let's keep going. So we have plus 2 times 3 is 6 minus 2 times minus 2x is minus 4x plus 4. Let's open the entire bracket. We are going to be having 3 times 9 is 27. 3 times minus 12 is minus 36x. 3 times plus 4 is plus 12x squared plus 6 minus 4x plus 4. You could collect like terms and we could rearrange. And we're going to be having 12x squared. Yes, minus 36x minus 4x gives us minus 40x. Are we together? 27 plus 6 is 33 plus 4 is 37. So this is f of g of x. I hope you understand it. Alright, let's go to the next one, f of h, because I don't want this to take too much time. F of h. Same thing, writing f's function first, because h would be inside f. So I'm going to be having 3x squared plus 2x plus 4, which is f function. Are we together? Then inside every x variable, I'm going to be putting h function, which is going to be 3 into bracket 5x squared squared. Are we together? Plus 2 into bracket 5x squared plus 4. What did you notice? For every x variable in function f of x, I just replaced all of them with h of x, a new function. So look at it, this x variable, h of x, this x variable, h of x. So let's continue foiling and let's do law of indices. 5 squared is 25. X squared raised to power 2 is x raised to power 4. You should know indices by now. Plus 2 into bracket 5x squared plus 4. Now let's just open all the brackets all at once. This gives us 3 times 25 is 75x to the 4th plus 2 times 5 is 10x squared plus 4. And there's nothing else to do. This is f of h. Quite excellently done. Very easy. If you do not understand, do well to rewind the video and play it for as many times as possible. Yeah, going on to the next thing. G of h. Do me a favor, pause the video right now and try to do G of h on your own. Alright, let's solve it together. Now you have done it on your own and let's find out if you did the right thing or the wrong thing. G of h means h function exists inside g. So I have to write the exterior function first, which is g's function. 3 minus 2x. And every single place I have x in my g function, I'm going to be putting the h function, which means I'm going to be having 3 minus 2 into brackets. What is h's function? Let's check it. 5x squared. 5x squared. Remember, h function is 5x squared. Can you see it? So I'm putting it inside the x variable of g. And let me foil. I'm going to be having 3 minus 2 times 5 is 10x squared. And this is all. This is g of h. Quite excellently done. Nothing more to do. Are we together? And what's the next thing? G of f. G of f. G function is the most exterior because f function would exist inside G's function. So I have to write G's function first. And in every single place I have x, I'm going to be replacing it with f function, which means I'm going to be having 3 minus 2 into brackets. And let's write f's function again. 3x squared plus 2x plus 4. You got it. 3x squared plus 2x plus 4. Are we good? So let's open the brackets. And we're going to be having 3 minus 2 times 3x squared is minus 6x squared. Minus 2 times plus 2x is minus 4x. And minus 2 times 4 is minus 8. So I can collect like terms, and I'm going to be having minus 6x squared minus 4x. 3 minus 8 is minus 5. And that's it. I'm done. G of F. Yeah. Let's try the other one on your own. Let's try and do it together. But try it first on your own. F of G of H. F of G of H. Look at all the functions, and you're looking for f of G of H. Pause the video and try it on your own. Yeah, if you have done that, you should get something related to this. If you have to start from f's function first, which is going to be, well, 3x squared plus 2x plus 4. And we are going to be replacing all the x values with G's function, which is going to be 3 into brackets. What is G's function again? Let's go and confirm. 3 minus 2x. 3 into brackets, 3 minus 2x. Yeah? Plus 2 into brackets. 3 minus 2x. Plus 4. Yeah, this is squared, please. Don't forget that. Because it's 3x squared. And we are still not done. We are still not done. Let's do ourselves a favor. Let's expand this first before we throw in H's function. And we're going to be having, so it's going to be easier for us to work with rather than just throwing so many squares at the same time. So we are going to be having 3 into brackets. If you expand this, we are going to be having 9 minus 12x plus 4x squared. That's if you know how to expand this bracket. Plus 2 into bracket, 3 minus 2x plus 4. Let's open the entire bracket. I'm going to be having 3 times 9 is, okay, don't let us even open the entire bracket. Now let's start putting in every x value in this function. Let's start putting H's function. And H's function here is just, what is H's function again? 5x squared. So I'm going to be having, watch this. 3 into bracket 9 minus 12 into brackets, I'll put it in green. 5x squared. Are we together? Plus 4 into bracket 5x squared squared. Because there's a square on this x here. Do you understand it? This is the x, this is the x. So we have done this part. Plus 2 into brackets 3 minus 2. What is our x? Replace x with 5x squared. Are we together? Plus 4. Now let's open the entire bracket once and for all. We now have, okay, let's do from the interior first. 3 into bracket 9 minus 12 times 5 is 60x squared. Plus 5x squared squared is, watch this, 4 into bracket 5 squared is 25. X squared is x to the 4th. That's x squared squared is x to the 4th. So if I do 4 times 25x to the fourth, I'm going to be getting 100x to the fourth. So let me just clean this and write 100x to the fourth. If you didn't get it, rewind the video again and watch it till you do. So I have done this, I have done this, I have done this. Plus 2 into bracket 3 minus 2 times 5x squared is minus 10x squared. It's very easy. Plus 4. Now let's open the entire bracket. 3 times 9 is 27. 3 times minus 60 is minus 180. So I have minus 180x squared. 3 times 100 is 300x to the fourth. Plus 2 times 3 is 6. 2 times minus 10 is minus 20x squared. Then plus 4. Now I can collect like terms. So let's start from the highest power. We have 300x to the fourth. What's the next power again? Squared. So I have minus 180x squared minus 20x squared, which gives me minus 200x squared. Minus, yeah. And we have 27 plus 6 plus 4. 27 plus 6 is 33 plus 4 is 37. Bam. And we are done. F of G of h of x. Easy. Yeah, I'm going to be stopping for now. For today's class, we'll continue on functions, solving more questions and more exam questions on functions in our next class. Till then, stay blessed. Have a nice day. Bye.